That's it. It seems like our networks and everything is running. Hi, guys. If you can just give me an indication, please. I should have an icon on my screen, and you should be able to hear me. Jaco, thank you very much for acknowledging. Is my voice coming through? Okay. All right. Alan, thank you, guys. I really appreciate you spending a few minutes with me. My name is Hannes Willemse. I'm part of the non-redundant stock at Miro, and I'm here for a few years. I'm part of the training team. If you guys come for MikroTik training, I know a few of you will know me by now. Jaco, you say Mac is doing it. Right, so I'm going to keep you busy for about half an hour today. We're going to discuss a little bit of power solutions. And we're mainly going to have a look at solar for our towers. We quite often sit with scenarios where we've got a tower somewhere in the middle of nothing, and we need to get power to that tower or that hotspot or high spot of ours, and it's problematic. So what I will do is I'll try and give you an idea of what's available from us and what solutions we can implement for you. We're going to have a look at the solar panels itself. Then you're going to have a look at the batteries, the regulators, converters, inverters. We'll have a look at a little bit of UPSs, although that's not part of solar. It's also a very handy addition to your high site. Should the normal ESCOM power go missing, you can run with it. We're going to have a look at if you can monitor the stuff from remote. Obviously, surge protection is part of it. And then what we will do is we will quickly run through a little bit of a planning session so that you can just get some sort of idea what amount of solar panels and batteries you need for your system. That will be very brief, and you can follow that up afterwards by contacting myself or Elmo, and we will gladly assist you with that. But that's the aim of this little session, is that we can also just show you how to do your planning. Right, let's start. What's a solar panel? Solar panel is converting the actual sunlight to electricity. There's a few versions available. We sell the poly panels at the moment at Miro. And in general, you get from about 80 to 415 watt panels from us, ranging 12 volt to 24 volt. You can build up combinations between this. You can take it up to 48 volt by using 2 24s or using 4 12s, etc., etc. So you are not limited, but the range of the solar panels at the moment is 12 to 24 volts. So you build up in combinations, and you can do that. Although the slides say any combination, it's in combinations of the same or similar panels. Not a very good idea to, for instance, put the 300 watt panel and the 100 watt panel in the same configuration. The power, there's a big difference, and that might cause some problems. But guys, I'm watching the screen also, my questions and answer screens. So if you feel you want more information on anything specific at any time, please just go ahead, ask a question. If I'm able to answer that, I will immediately do that. Otherwise, we will just finish with what we're busy with, and we will have a look at the answer for you. A very, very big part, obviously, of solar power or remote power is batteries. And with batteries, that's one of your expensive portions of the whole system too. At the moment, Miro is selling lead acid batteries, and we've got 3 different versions of it: the normal lead acid, the AGMs, and the gel batteries. And as you can see, there's a little bit of difference in the specs. The normal lead acid battery is about 3 to 5 years. The AGM 7 to 8 years, and the gels also 7 to 8 years, and the amount of cycles that you can do. Of interest and of note that you must be fully aware of, look at the spec sheet. All the life cycle for batteries is indicating at 50% discharge. So we've got a little bit of a limitation on our normal lead acid batteries, in the sense that lead acid batteries don't like to go far below 50%. That will reduce this life cycles tremendously. So we want to keep our solar systems to be within 50% discharge. We will discuss that in more detail when we get to the planning of your system. Then the new lane in batteries, the lithium ion, and I tell you, watch this space. Myra is busy at the moment processing, getting the processes in place to also be able to deliver lithium ion batteries. So what's the big difference between lithium ion and lead acid? Number one, it's smaller. It's a much smaller battery. Number two, it can charge faster. But now you must also take in consideration, if you want to charge faster, you must supply more power. If you need more power, you will obviously need a bigger charger, and you will also need thicker cables and all those type of things. So although it's an advantage, you must just be sure that you actually plan for it. You need more solar panels that works because you need higher amperage to be capable of charging faster. And then one of the beauties of this device is also they can discharge quite easily to 80–90%. I've seen tests where the guys discharge quite often to 90%, and it's not deteriorating the battery a lot. And then they also have a much better temperature stability than lead acid batteries. So immediately the guys ask, so why do we actually still keep lead acid batteries? If the lithium battery have got so much advantages over the lead acid, why? And I think the last point is a very valid point, it's price-wise. Price-wise, the lithium-ion batteries is easily up to 4 times the price of a lead-acid battery. And now you must compare all the advantages to the price. I think the major determination factor is going to be your space. If you're on a tower and you need all the space you can, you will try to be as small as you can be, and then obviously lithium is not debatable, that will be the answer. Cycles on lithium, they give you about 3,000 cycles. So if you take that, it's in the region of about 10 years. Yeah, I've got questions here, Dieter, the cycles and the durability. Yes, that is obviously lithium. If the price can go a little bit lower, there's no debate what you use. You use lithium. But at the moment, you must compare your price in addition or to the advantages the battery would give you. And a normal lead acid battery, about 4 times less the price, will last you about, say, 3 years. So 3, 6, 9, 12 years. If you treat the battery well, lithium battery about 10 years. So you're pretty much in the same price point with the two. But with the lithium battery, you must take that out upfront. So you must invest that now for the 10 years to come. With the lead acid battery, you at least got a lower startup cost, and you can invest in 3–4 years again. So this is a debate that I think we will still have for many years, and I do believe that lithium is going to take over. At this stage, obviously, the lithium in a price point is making it sometimes difficult for you as a startup to immediately start with lithium batteries. The major disadvantage in my specific situation is space. Lead acid batteries are sometimes up to about 3–4 times bigger than a lithium battery, so you do use a lot of space. Jaco mentioned the fire hazard of lithium and stuff. Yes, as I said, there's still a few things that would give lead acid definitely still space to survive and to live on for, and I do believe for many years. You cannot deny the great work lead acid have done for us in this scenario for many years now, and I do believe for many years to come. The technology on the batteries also go better. If I can go back one slide, have a look at the normal lead acid battery, where we've got about 200 to 220 life cycles, discharge cycles. Where with the gel batteries now, we're up to 600. So with 600, if you do it on a daily basis, that's definitely already 2 years that you can go from fully charged to fully down, which you normally don't do. And 7 or 8 years. So whilst the lithium batteries definitely do have advantages, you cannot just say, that's it, we're going to go lithium ion and don't have a look at the... Students ask lithium ion versus gel, basically the same, sir. The major difference between this is a size. Size definitely play a role. The gel batteries cannot charge as fast. You can hit a lithium battery quite hard with amps and it will survive it. And then the other big difference is the discharging. Even with the gel batteries, you are limited to the 50% discharging or the death of the discharge, where with the lithium batteries, you definitely do have an advantage. All right. So let's move on from the batteries on to the regulators. With the regulators, you basically get two major different technologies in the regulators. You get the pulse width modulation and you get the maximum power point tracking. Now, the biggest difference between these two is with with pulse width modulation, you still work, I want to say the analog way. You still convert the extra power that you've got, you convert that to heat, and you'll see in the pulse width modulation, all the pulse width modulation equipment, you've got big heat sinks on the output drivers, and if you push 24 volt in and you only want 12 volt out, there's a 12 volt difference between your input and your output, and that actually it disappears as heat. It must convert it to heat because it's getting wasted. So pulse width modulation, once again, for many years, doing a job very well, but you need to be close to your output voltage. So if you work with a 12 volt battery, you would preferably be very close to 12 volt input. You obviously need about 3 or 4 volts above 12 volts so that it can regulate down to 12 volt. But if you start going like 48 volts, there's no such a system. But if you have to go 48 volts and just 12 volt out, that thing is going to burn your hand, because all the extra power gets anticipated as heat. Where with the newer maximum power point, the energy actually just get converted. So if you push in, and that's a trend now, that you, for instance, on your solar panels, you series your solar panels so that in the end you've got like 100 to 150 volts or even higher voltages. That would make your cabling from your solar panels to your charger much, much thinner, because you don't need to run all the higher amps to get the wattage. And the MPPT systems can handle that. So you can have a much higher voltage input, to give you a 12, 24, 48 volts output. And the efficiency of the systems is very close to 100%. If you go look at the spec sheets, 97% and 98% is not uncommon. You get a lot of them that actually run in that range. So for a little small system somewhere, LED light, those type of things, most probably not MPPT, because they still price-wise a little bit higher than the pulse width modulation. But definitely in the more sophisticated systems, no doubt that you go MPPT. They just the newer technology, and they do a great job. Then also in our portfolio, we've got the DC to DC converters, and that's a very important part of a solar system. You will notice that you're going to get maybe a camera that's on 12 volt, and you're going to get a wireless radar that's going to be on 24 volts. What solar system do you invest in? And that's going to depend on a lot of factors, but you will obviously go either 12 volt or 24 volt. I like to go for the higher voltage, because higher voltage is always less amps for the same watts, and your cabling needs to be a little bit thinner. But let's go to the scenario where I use the 24 volt system, and now I need to power a few 12 volt pieces of equipment. Then obviously I need something to convert that 24 volts down to 12 volt, or the 48 volt down to 12, and that's where we get in with our converters. On the other hand, also true, I've got a 24 volt system, and now I want to do 1 or 2 PoE cameras, which runs on 48 volt. So I will obviously need a step-up converter that's going to take my 24 volts to 48. Now we're fully capable of assisting you with all that. We've got different wattages, we've got different ranges, and we should be able to assist you with whatever system you build and with whatever equipment you want to power. Then on the inverter side, inverter start taking you to 220. 220 start to work with COCs, with certificates and all those type of things. it's a little bit of a danger part for us, but it's available and we can do that. So you've got like a DC system, and now you've got a LCD screen that work on 220 volt. Obviously, you will need to power that thing with 220, and that's where the inverters come in. On the inverters, I think the only advice I'm going to give you is always try to get a true or a pure sine wave converter. What they do is they use PWM once again, and they simulate a sine wave to the point where equipment will not realize that it's actually a converted signal. So that thing comes out 50 hertz, 220 volts, and it looks, if you check it on an oscilloscope, you will see 220 volt AC. A lot of equipment in the lower price bracket is the so-called simulated sine wave converter. What a simulated sine wave converter do is it cannot work at the same frequency on the pulse width modulation. So you, as a matter of fact, you get like a stepped DC system. So it's taking it up to 10 volts, 20 volts, 30 volts, whatever the case might be, and push that through a transformer, but it is in steps. It's not a smooth action. And especially the modern equipment power supplies, not the old transformer linear power supplies, the new switch mode power supplies, don't like that. So you're endangering your equipment blowing up the power supplies by using simulated sine wave converters. So I do believe spend a few rand more and get the pure sine wave converters. Then on the other hand, if you're in your caravan, you just give power to a few globes and whatever, no use to spend the money on the sine wave converters, or the true sine wave converters. Then something that, and once again, it's going to depend on your scenario. I'm a big fan for knowing what's going on. So I've got a site somewhere. Is the sun shining? I don't know. Can we check it up in some way? Yes, we can. We've got monitoring equipment, so you can have your equipment monitored on your cell phone or on your PC, and then also the Victron equipment have actually got is cloud-based. So if you've got different sites, you can link them all to the same cloud, and you can monitor on one place. You can monitor all your sites and know exactly what's going on. Very handy for, especially for maintenance. If something starts going wrong, if you see your batteries start going because the time limits, they're not running for 24 hours anymore, they're now running just for 20 hours. You get full graphs, you get a full indication of what's going on with your system. So that's very, very handy to have this monitoring. And that you won't get on the cheaper equipment. The little pulse width modulation devices that you buy from, bring in from China or whatever, they haven't got any ports or connections to allow you to do this. I would think fairly important. Then surge protection. I think a lot of guys underestimate surge protection when it comes to DC. They believe this is a DC system and DC don't surge. I think the last sentence in this is doing it all for you. Remember, solar panels might cover the whole roof area. Do you realize how many square meters are you exposing to the elements when you work with solar? If you think about your 220 volt grid feed, it's coming in on a cable that's a few millimeters thick and it's running underground or whatever. So as a matter of fact, that is really fairly protected. If you think about your solar panels is lying how many square meters on your roof? So that stuff is really, really exposed to the elements. And if you don't use root surge protection and you don't earth your panels well, I can nearly guarantee you're going to have equipment failures a little bit later on because of surging. So please don't underestimate surge protection in a solar system. Let's have a little bit of look to do some planning and just give you some sort of idea how much panels and batteries and whatever they need. And to do that, I'm going to just immediately make you aware of two things. And I'll put it in bold here. I tell you, solar depends 100% on sunshine. There's no doubt about it. If the sun don't shine, you don't have power. And I must overemphasize that, because lately we had a few quotes for guys who had really critical systems, alarm systems, access control systems, cameras that monitor sensitive areas, and they want to put this purely on solar. I don't think that's very wise. Can you predict how much the sun will shine? We've got averages, and I'll show you now. We've got maps, and we can work fairly well on averages. But I've also been in scenarios here in Centurion where it actually rains and it's clouded for 3, 4, 5 days in a row. So can you guarantee that your system will run always? The answer is no. So if you've got a mission critical scenario, you must have more than just solar. Just be very well aware of that. And then the other thing people misjudge themselves a lot with, and I think is well worth just thinking about the principle. I've got a little radio and a camera sitting somewhere, and this thing must be on 24/7. So I'm pulling power 24/7 from this system. It's running always. How much sunshine do I have per day? We'll have a look at the charts. Now let's say we've got 4 or 5 hours sunshine. So you must remember that if I'm pulling 1 amp for 24 hours, I'm actually exhausting my system with 24 amps. If we just talk amps. And now I must recharge this in, say, 4 hours. So I must recharge at about, what's it, about 7 amps, nearly 7 amps an hour that I must recharge, although I'm discharging only at 1 amp. And that's a very important factor that you must remember when you design your system. Guys put in little thin wires because, gee, I'm just powering a 1 amp scenario. But in the meantime, I'm charging at much higher, so my wires and stuff is not going to handle that. So be aware of it. You're pulling power out for a very long period, but you can only replace that power in a very short period. So what's the first thing you need to do if you want to assist somebody in the, you must work out what's the power requirement from your client. What do you want the power? If you haven't got the wattage that you must supply, you're in a dead end, you cannot do that. So once we've got the wattage, then we can start calculating the solar panels that we're going to need. We can calculate the regulator that we need, and we can calculate the batteries that we need. So very important, we must always start off with what's the wattage of the system that we need. Now a little bit school science again. Let's go back to watts. How do we define watts? Watts is my wattage is a summation of my volts and my amps. So that's how we work out what's in a system, and it's not dependent on voltage. It's dependent on it, but your terminology is power, so you can work out watts for any voltage. Right, so we've got a 7-watt system and we've got a 10-watt system. We add them together and we've got 17 watts. Now 17 watts, that's the instantaneous power. So if you want to run that for 24 hours, we will obviously have to work that out over a 24-hour period. And that's going to take that 17 watts up now to 412 watts. So our system needs to supply 412 watts for 24 hours. It's very wise to add a margin to this. And yeah, different people have different ways. We like to work with about 30%. So we will lift our power requirement by about 30%. That's for insufficiencies in your converters and batteries and cables and sunshine. Although we've got very good averages, we cannot guarantee it. So we make provision for about, so that initial system at 412 is now sitting at about 540. Just an idea of how we're going to get the hours that we're going to recharge this 540. So this is what we're going to pull out of my system for 24 hours. I must push it back into my system somehow. And to do that, I must determine where I'm situated. So as you can see, we in South Africa, we were about between 3 and 5 hours sunshine per day. You'll have to have a look specifically where you are, and then you can determine that. So sometimes people laugh at me when they say they want planning for a solar system, and I tell them, give me your coordinates, and they don't understand that very well. That's very, as you can see, South Africa is really a nice sunshine country, so we've got a lot of it, but you do need to know where you are to do the planning 100%. Then to work out, we were in an area where there's about 5 hours. So what we did is we divided that full amount of power within 5 hours. So we need 107 watts instantaneous to replace our 500 watts at the specific moment. So our panels must be able to supply at least 107 watts. Now we've got a little spreadsheet here, and this is for 12-volt panels. So we've got small panels, 50, 60, whatever, and then 2 panels of 60 watt will give me about 120 watts. So that's that. That's what I'm going to use. I need 2 panels anyhow to go to 24 volts. Remember, even if it doesn't matter if you serial panels or if you parallel panels, the watts will go up because either the amps is going to increase or the voltage is going to increase. So in determining how much we're going to need to charge the system, remember, solar panel 60 watts, 12 volts is going to give you 5 amps. But the spec sheet of this solar panel, it tells me I'm only going to get 3.35 amps out of this system. So be careful not just to do a mathematical calculation, but have a look at the spec sheet, what they say you're going to get out of this panel. So we're going to get a little about 3 amps out of this system, 3.35. And once again, we're going to add about a 30% margin. You know that if you get a charger that can do 3 amps, 3.35 is going to burn that. So I'd rather go a little bit higher. And unfortunately, at this stage in our stock, we will only have the smallest we will have is a 10 amp charger. So we will use the 10 amp charger. Here's the specifications. Can handle 75 volt in, it can handle 10 watts, 10 amps out. So this is the little charger we will need to get. In selecting our batteries, we've calculated everything in watts. So now we must fall back to amps because batteries are specified in amps. And to get your amps, you must divide your watts by your volts. So we're going to take our daily watt hours, that's 540, 536 something. We're going to divide it by 24 because that's the voltage of the system. It's nothing to do with timing. And that gives me about a 22.5 amp hour battery when it's a normal 12 volt battery. Remember when we had a look at the spec sheet, we can only discharge about 50%. So we can only discharge about 50%, so we must double up our battery capacity. Doubling up the battery capacity will give us about 45 amps. So to run this system, I'm going to need 2 12-volt batteries at 45 amps per hour to be able to handle this load. And that's basically that. And I know there's quite a few things more, but if you do go through the slides again, this will give you a very good idea to estimate what size of panels you must have and what size of battery you must have. The mathematics is the same for all the systems we're running. And that's how easy it is to do that. The benefits of going off-grid? Yes, this for sure. We're going to have our own power. We will be more up. If you think about the load shedding and stuff, we will have less power that we need to pay. Our bill is going to be, and we're part of the green guys also. We're going to reduce the carbon print. Just very quickly, maybe another 2 slides here. Think about UPSs also being on a site. We also stock a full range of UPSs with which you can run your tower or your scenario when we're out of power. And last one I want to mention to you is the Aconet safes. Obviously, batteries is a very, very popular item, and they rob eyesights very often for batteries. So I think it's a very good idea to get a safe, and we can help you with that. Gentlemen, my time is very close to finish, and I think I'm very close to the last slide. So if you want to use our contact detail, you're more than welcome to contact us. And you're more than welcome to send us any questions also. We would gladly like to answer all your questions. I'm on my time limit here. I've got a lady that's jumping up and down here at the door and flashes on her watch. I don't know why. I don't understand that. But I want to thank you guys. I really want to thank you guys. And unfortunately, I haven't left. I've noticed there's not much time for questions. But please, anytime, send me an email, send Elmer a mail, and we will gladly answer you if we can. All right, guys, as I said, unfortunately, I've overstepped my timing a little bit here. So please, if you've got questions, send me that mail and I will try to answer you immediately. Peter, thank you very much. I appreciate it.